Hey guys, sorry, I feel like kind of cold, so my throat is not really good today. By the way, uh, yeah, today we've already learned about the reactive powers of action in power system, right? And with that base of knowledge, we try to make a more deeply uh, penetrate into the deep knowledge, and we will try to drawing the pager. This is really important. So first of all, yeah, I will try to draw. Let's see. So first of all, we need to know first for power system, right? It is G, and then yeah, and we need the P and Q. Try to do also drawing this, okay, guys? When you have time. Load motor. So this is drawing the power system, uh, briefly, you know what I mean. So here, you guys wanna know is here is sending and sending and the voltage here because of near the generator part, it's sending the power, right? And here you see uh for receiving and the voltage, receiving and sending, near the road, it's receiving, right? So first of all, we need to make sure voltage equation. So look at that. Vs equal to VR plus, what is it? This part we say, sorry. This part we could say voltage drop, right? So J. Oh, and in the line, you know what I mean? In the line, the R is really small. So we just, think like there's no just a resistance, like this part. So only we could say JX. I mean, compared to these two values, R part, the real part is really small. So all 90%, 99% is JX part. So we say JIX. And I mean, actually, we needed edit R, but with drawing the page, I wanna you guys more understand easily, you know what I mean? And there's also two reasons, like R is just so small, so I said like ignore the R, you know what I mean? So this is we made a voltage equation, right? So we will explain in the page, the page. Pager is having a magnitude and angle, you know what I mean? Like degree. So we need our reference point here. Receiving part is important part because actually we use it, right? From here we get it, the voltage, right? And then yeah, so that's why this receiving part is also this R0 is a reference point. And I said in daytime or general time, we use lots of load like a motor or whatever, and petrol is working, right? So that's why the I is mostly lagging, in daytime. So I here's theta, right? But we wanna know this J. J is I said people, you guys, J is precede 90 degrees, and A is precede 120 degree. J is right? So look at that. So from here, 90 degrees, yeah, yeah, 90 degrees, right? So precede the 90 degree. So pager is like this. Hey, I will draw it again. Sorry, guys. Here, I want to series 3 R 0, this point, and this is I, right? And minus theta, theta. And then 90 degree, right? Almost, I mean, there's two way, like from here to 90 degree, or from here, 90 degree. Mm, 90. So J is, 90 degree, precede, right? So edit this one to here. And then the last one is here, 3S. So we can see now. Now VS part is, sending the end voltage part is, having a higher number. I mean, the line itself is kind of longer than the VR part, right? So this is our general pager, you know what I mean? But we also learned if we wanna improve our power factor, we add it here. Look at the guys. We add it here like capacitance, right? So let's see what happened if we add a capacitance. Okay. So look at that here. VR, right? So same, but down now our I is here lagging, right? But since we add a capacitance, right? Capacitance is capacitor is a C, right? And it provided, I mean, it's consumed, C itself consume lagging, leading, right? Leading here, C. So first of all, you guys also need to hit here. Sorry guys. Here I, and here's IC, and here's I will say I load. So I equal IC plus I load. You know what I mean? So look at that. So our lagging is here, right? And then capacitance here. So if we both of them adding, this is the I now here. You know what I mean? So first of all, I didn't explain to you guys. Look at that here. First of all, we must make it this straight line. That's looks like not straight, but it have to be straight because we wanna keep the P active power, right? Active power is P is just the same. We only wanna know about the reactive power. You know what I mean? So actually, my drawing is not good right now. So what I wanted to is yeah. Actually, it gotta be like that. I and then column actually. Yeah. So now, look at that. Here is I, right? Here is IL. So what I mean is, no, So what I mean is, this I is, since we added the capacitor, the I is decreased. The I itself is magnitude is the distance, you know what I mean? The length is shorter than this, right? Yeah, I wanted to say is this because before we didn't add this capacitor, I is the same, right? But since we add a C, there's a new formula for current, right? So if I draw it again, look at that. Here we are. So here's I, right? Before added C, right? But since we add the C, what happened? Let's see. C, right? But this is when C is, just receiver part. When C is, like being a generator part, like giving reactive power to the load, which means it's gonna be a generator part. So that's why C actually gives like this way. You know what I mean? So IC plus IL is I, right? So let's see here. Yeah. So the magnitude itself is, as you guys can see, gonna be a smaller, right? The length itself. And we say this is, we improved the power effect. And if we add more C here, what happened? Look at that. If we more add a C here, what happened? Look at that. And this is now I is. So this part we say is the power factor is 1. And how we draw it? Okay, VI. And I is here, right? But I is JX, right? J is, where is it? I multiply JX, right? J is 90 degrees precede, right? So here, 90 degrees. So I, J, X is here. And then gonna be VS is here. No, give us a. So yeah, 90 degrees here. So what I mean is we put it here, right? I, J, X, right? And then we add here VS, same thing for VS. This is when the power factor is 1, right? And then let's see. And then one more. And if we, added more the capacitors, what happened? Look at that. First, we need to voltage equation. Always have to remember, okay? Vs 3R plus I J X, right? So 3R. And then now what happened? Let's see. Like if we like add too much capacitors, So now it's lagging here, right? I see here. And then we need to know I line is I line equal to IC plus I load. I will say I load, right? So IC is if it's here, so JX is 90 degree, right? 90 degree, yeah. So look at that, what happened from here. So we add this here, the IJX, right? 90 degrees precede here, right? And then we add here black. Yeah, VS. What happened now? the sending part of voltage, is the shorter than VR part, right? VR part is here, right? VR is more bigger magnitude than VS. So we say this is a ferranti effect. So like, for example, look at that, guys. In the daytime, we use too much of a load, right? Mostly. I mean, factories are like working, like running like 24 hours, constantly. But like most of the people, they work in the daytime, right? So we use lots of load in the daytime. But in the daytime, we needed more and more powers. So that's why we provide more reactive power from the capacitors, But in nighttime, it's reversed. We already supplied lots of reactive power. So in the, line, conductor line, there's lots of capacitors, capacitors left. So, that time we needed, absorb this reactive power because now VR part, receiving and the voltage part is higher magnitude than sending voltage part. You know what I mean? So it could cause like insulator damage or making heating. You know what I mean? It's not good phenomena. You know what I mean? So after then, what we need to add the reactor, coil. You know what I mean? So let's see here, right? So now we can see here, here, and then this is VS, right? So coil is here, this part. Coil is this part, right? And then C is leading. Coil is lagging, right? So let's see. First of all, as we know here, here's leading IC is here, right? But since we add L, what happened? So first of all, we need to make sure here P is constant. P, P and Q, right? P, Q. So we need to add it first. Sun. Drawing is not that easy with using this. Which color is better? This color. No. You guys can see this? Because now IC plus IL, we add it, right? Add is a reactor, we add it here. So that's why the current is now lagging. You know what I mean? It changes it too. So which means if we doing more this, what happened? Doing the lagging here, right? Now, here. And VS, VR. VS is more longer than VR, right? This is the general situation. So we don't like penalty effect. So that's why at the nighttime, we add more reactors to absorb the reactive power from the line. You know what I mean? Because we don't want to get voltage, receiving part of voltage. We don't want to get higher than the sending. You know what I mean? So let's move on first. Yeah. So first of all, yeah, what I said was this first picture is I is lagging, right, in the daytime. So 90 degrees 9 degree. So kind of lagging, right? And then we edit this is put here and then put here. But since I mean the black line, but since we added C, what happened? So IC plus I make it this green line. You know what I mean? So which means that the power factor is improved. But what if, like now, I is a third picture you can see. I is leading, right? But if we add L inductor, what happened? So if we add both of them here, and this green line is it make it from the lagging, leading to lagging, change it I. You know what I mean? So this picture is just when the lagging, leading part, I is leading, right? Here. So 90 degrees here. If we add more here, and add here. So now VR part is bigger than VS. This is, it happened like in night time. And this is what I said was a ferranti effect. VR part voltage is higher than sending voltage part. It may cause like heat and insulator damage. That's for today's lecture. Thanks.